Okay guys, this worksheet that I'm assigning, I'm going to hopefully have some time in class with them to do some of it, and then have you guys do the rest for homework. I did this in the past because I know students were struggling a little bit with, is it polar, is it non-polar? I'm hoping maybe, I can't foresee into the future, I'm hoping that you guys don't have that issue. You guys have kind of not had the issues I've seen in the past on some things, so I'm hoping maybe this one isn't either. But either way, I'm planning on doing this worksheet. So it's very similar to the one that you saw earlier, except when students were struggling with this stuff, I was trying to walk them through steps on how to do this. So I'm going to do PVR3 with you guys, and that's what I'm going to do with the kids in class too. So the first step is, finding your valence electrons. So phosphorus is 5, bromine is 7, but there are 3 of them. So there's 26 altogether. So we've got P, my phosphorus, I'm going to attach my bromines. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. All right, so the shape of this one is going to be a trigonal pyramidal. If you were to look that up, you have 3 bonded in 1 lone pair. So it's going to be something, that dotted line saying it's kind of back a little bit. It's going to look something like that. And it says, indicate the dipoles, show the arrows. So that's what I want is my arrows. So I'm going to go back. I go to 10.4 notes. I know it's here, this one. I'm going to look at phosphorus versus bromine. And bromine's got the higher number, so that's going to have my arrows. I'm going to put my arrows there. Now, I want to know the change in the electronegativity of the bond. So let's look at that. If I'm looking at just phosphorus and just bromine, that is 2.8 minus 2.1, and that's going to be 0.7. So that tells me that it is polar. Now this says, does it cancel out? It doesn't cancel out. What I mean when I say cancel out, I'm like, do these negative arrows all cancel each other? And they don't. I have poles. I've got negatives here, and I've got a positive on top. So no, it doesn't. So it stays polar. Here's the thing is that you can have some things, when you subtract the numbers, it looks non-polar, but then it cancels, or it looks polar, but then it cancels out, which makes it non-polar. So say, for instance, that this was a trigonal planar. Say it was this. My arrows are pointing out, and I would say it's 0.7, so that says it's polar, but does it cancel out? It does. Negative, negative, negative. They all are negative, so yes. So it went from polar, they canceled each other out. Now it is non-polar. I'm hoping that isn't too confusing. I'm hoping that makes some sense. I just want to know, do these basically, was it a polar molecule when you went to subtract, and now when you look at the shape, it's not? So anyways, if you need any help at all, let me know, because this one's for a grade. So let me know if you're struggling with any of this. You're going to have just some linear, like BR2 is going to be linear, HCl is linear. We did that one on a previous worksheet together. So let me know if there's anything that you need at all with this, and I will get back with you. Have a great rest of your day. Have a great rest of your day. Bye.